To understand the concept of tungsten inert gas welding, let us consider two metal plates and try to join them with other along the edges. For this, we need a TIG welding setup that consists of a welding torch consisting of a tungsten electrode, a gas cylinder containing an inert gas, say argon, and a DC power supply unit. Now let us connect the gas cylinder to the welding torch through a gas hose. Now we connect the negative terminal of the DC power supply to the tungsten electrode acting with the help of a wire, and connect the clamp to the positive terminal of the power supply. Now let us place both the plates together such that their edges touch each other. Then we bring the welding torch above the contact interface of the plates. Now let us switch on the power supply and open the gas supply from the cylinder. Now, as soon as we press the trigger on the torch, we see that an arc is produced at the mouth of the torch. Inside the torch, the electric current flows through contact tube, and gas supply flows along the inner boundaries of torch. We see that the tungsten rod does not melt, thus acting as a non-consumable electrode, and the metal plates present beneath the torch gets heated by the electric arc. Now let us introduce a filler rod inside the electric arc. We see that the filler metal, due to its low melting point, melts and gets deposited at the contact interface. Argon gas leaving from the torch protects the electrode arc and the molten filler metal from reacting with the surrounding air. Now let us move the torch and filler rod all along the contact interface, thus depositing the molten filler metal there. The molten filler metal solidifies on cooling and a continuous weld seam is obtained. This process of joining two metal plates by using a non-consumable tungsten electrode and an inert gas is called inert gas welding. Thus we can say that tungsten inert gas welding, also known as gas tungsten arc welding, is a welding process where electric arc is formed between a non-consumable tungsten electrode and the work pieces, and an inert gas is used to protect the electrode arc from reacting with the surrounding air. Some of the main advantages of tungsten inert gas welding are as follows. Stable arc is produced at a constant current level. No flux is required. Produces high quality welds in non-ferrous alloys. Some of the main disadvantages of tungsten inert gas welding are as follows. The process is highly expensive. Tungsten electrode may get contaminated with the molten metal. TIG welding is commonly used in welding steel balustrades and stainless steel piping systems. Note that tungsten electrodes are generally mixed with little amounts of thoria and zirconia to carry high currents and maintain a stable arc. Related terms are